House design in Google SketchUp, a comprehensive overview. Designing a house in Google SketchUp, now known simply as SketchUp, offers a flexible and intuitive way for architects, interior designers, and even hobbyists to bring their home design ideas to life in 3D. With its user-friendly interface, powerful tools, and wide community support, SketchUp is a top choice for modeling residential spaces. Why use SketchUp for house design? Ease of use. SketchUp's drag-and-click drawing tools make it accessible for beginners, while still offering depth for professionals. 3D visualization. Quickly transform 2D floor plans into detailed 3D models for a realistic view of space and form. Component libraries. Access thousands of pre-built models, like furniture, fixtures, doors, windows, from the 3D warehouse. Precision and accuracy. Design with real-world measurements, ideal for creating detailed blueprints and construction documents. Customization. Easily apply materials, edit textures, and modify lighting for realistic renderings. Steps in designing a house in SketchUp. Create a floor plan. Start with accurate dimensions. Use the rectangle, line, and push/pull tools to form walls and structural elements. Import CAD files or hand-drawn sketches to trace over. Build the structure. Extrude walls from the floor plan. Add floors, roofs, stairs, and ceilings using basic tools or plugins. Model architectural features like columns, beams, and overhangs. Add doors and windows. Use pre-built components from the 3D warehouse or create your own. Cut openings in walls using the push/pull and intersect faces tools. Furnish and decorate. Furnish rooms with items from the 3D warehouse. Apply materials to surfaces using the paint bucket tool. Adjust scale and position for interior planning. Refine with layers and scenes. Organize the model using tags, formerly layers. Create scenes for walkthroughs or specific viewpoints, e.g. top view, interior, exterior. Rendering and presentation. Use built-in styles for conceptual views. Export 2D images or 3D animations. For photorealistic rendering, connect SketchUp with plugins like V-Ray, Inkscape, or Lumia. Tips for effective house design in SketchUp. Use groups and components to manage geometry and avoid unwanted changes. Model to scale from the beginning to ensure accuracy. Name and organize components for easier editing and sharing. Leverage extensions, via the extension warehouse, to enhance capabilities, e.g., for roof design or framing. Conclusion. Google SketchUp empowers users to design houses with both creativity and technical precision. Whether sketching out a new build, renovating a kitchen, or visualizing a dream home, SketchUp bridges the gap between concept and reality. With its growing ecosystem of tools and plugins, it continues to be a go-to platform for 3D house design. Creating a floor plan in Google SketchUp, now known as SketchUp, is a practical way to visualize architectural layouts in both 2D and 3D. Whether you're designing a new home, remodeling a room, or drafting a commercial space, SketchUp offers intuitive tools that make the process accessible for beginners and powerful for professionals. Steps to create a floor plan in SketchUp. 1. Set up your workspace. Open SketchUp and choose a template. For architectural designs, select the Architectural Design, feet and inches, or millimeters, template based on your region. Adjust units under Window a Model Info a units to suit your preferences. 2. Draw the floor outline. Use the Line tool, L, or Rectangle tool, R, to start outlining the outer walls. Input exact measurements by typing the dimensions after clicking or dragging a line, e.g., 20 foot, 10 for a rectangle. 3. Create interior walls. Use the Offset tool, F, to create consistent wall thickness, e.g., offset 6-inch inward from the outer walls. Use the Line tool again to add interior walls, aligning them as needed. 4. Add doors and windows. Use the rectangle tool to draw openings where doors and windows will be. Use the push/pull tool, P, to cut out these rectangles, turning them into openings. Alternatively, use pre-made components from the 3D warehouse, search door or window, and place them directly into your model. 5. Use groups and layers, tags. Group different elements, walls, furniture, etc., to keep them separate and editable. Use tags, formerly layers, to organize your floor plan, e.g., walls, doors, furniture. 6. Add dimensions and labels. Use the tape measure tool, T, and dimension tool, from the tools menu or toolbar, to mark measurements. Use the text tool to label rooms and other features. 7. View in 2D or 3D. For 2D views, switch to top view and choose parallel projection under camera standard views. Use the orbit tool, O, and zoom, scroll wheel, to navigate in 3D. 8. Save and export. Save your work regularly in .skp format. Export a 2D floor plan image via File Export, 2D Graphic. You can also export as a PDF or DWG file for sharing or professional printing. Tips for a better floor plan. Use guidelines with the tape measure tool to align elements precisely. Download furniture and fixtures from the 3D warehouse to enhance realism. Consider using styles to change the look of your drawing, especially for presentations. Conclusion. SketchUp is a versatile platform for floor plan design, allowing you to shift from basic 2D sketches to detailed 3D models with ease. Whether you're working on a personal project or professional blueprint, SketchUp provides the tools to bring your ideas to life with precision and creativity. After raising all exterior and interior wall to 10 feet, let's create lintel level for all doors and windows. To create lintel level, let's draw a rectangle where the doors and windows should be placed. After creating rectangle, pull down from wall level to 3 feet, because lintel level will be 7 feet. Lintel level, an overview. The lintel level refers to the height at which a lintel is placed above openings in a building, such as doors, windows, or ventilators. A lintel is a horizontal structural element designed to support the load from the structure above these openings and transfer it to the surrounding walls or columns. Purpose of lintel level. The lintel level is crucial in both structural and architectural aspects of construction. Its main functions include load distribution. It bears and distributes the loads from the wall or floor above an opening. Structural stability. It prevents the collapse or cracking of walls above door and window openings. Aesthetic alignment. It helps maintain uniformity and alignment in window and door heights, contributing to the visual harmony of a structure. Typical lintel levels. In residential construction, the standard lintel level is generally around 2.1 meters to 2.3 meters, 7 to 7.5 feet, above the floor level. For commercial or institutional buildings, the height may vary depending on design requirements and ceiling heights. Types of lintels. Depending on the construction material and span, various types of lintels are used. Reinforced cement concrete, RCC, lintel. Brick lintel. Stone lintel. Steel lintel. Wooden lintel, used less frequently today. Considerations in lintel placement. Span of the opening. Wider openings require stronger lintels. Load above. The weight of masonry or slabs above determines the size and reinforcement of the lintel. Material used. Each material has different structural properties, influencing the thickness and depth of the lintel. Seismic considerations. In earthquake-prone zones, lintel bands, continuous reinforced concrete lintels, are often required to improve building integrity. Conclusion. The lintel level.